So good morning, class, and you are welcome to our series on budgeting and budgetary control. When we started budgeting and budgetary control, we started by understanding that if we want to do a budget, we need to gather the data. So we did data analysis, and we also learned that we need to forecast. All right, and so in forecasting, we learn learning curve to actually forecast the labor that we will need and the labor cost that we will need. Um, Now we are going to go in there and learn how to forecast again. So this is like forecasting part two, and we are going to learn how to use regression. All right. So here we are going to learn about regression. Regression. Now, take for instance, your boss is traveling and he puts you in charge of production. And as he has traveled, he now calls you and said, "Oh, hey, Steve, or hey, Michael, I want you to give me the cost of producing, let's say, 20,000 units." Now, at that instant, what are you going to say? Are you going to say, give the answer straight away, or you are going to say, "Boss, wait, I'm coming. Give me 5 minutes." Realistically, you will say, "Boss, give me a little time. Let me organize myself and respond to you." And when you go and organize yourself and you are responding to your boss, these are the two uh, issues that are there. You would definitely give your boss an amount. So let's say you give your boss a total cost of, let's say, 100,000 cedis, or you give him a total cost of, say, let's say 60,000 cedis. Now, you were meant to produce 20,000 units of your product. All right. Now, the two things that can happen is that your boss may think that you are trying to cheat him by quoting 100,000 cedis. Yeah, that is what will happen. You feel like, okay, this guy wants to get some spare amount and use personally. It happens. But if you also tell him 60,000, what is going to happen is that the thought is 60,000 enough to actually deal with the 20,000 units? Are you doing a low balling concept there? So therefore, there is a statistical way that you can actually come with a confirmed total amount, and that is the regression. Basically, that is what the regression is promoting. So now, what then is regression? If we talk about regression, regression is just a statistical, it's just, it's actually a statistical methodology. And this methodology will help you examine the relationship between variables. What is our variables here? What are our variables? Our variable is that we want to determine the relationship between the total cost and the quantity that we are trying to produce. So it will tell us the amount to spend to actually get to what we are doing. We will get to the theoretical aspect of it quickly, but where we will actually learn the importance of regression and everything that we will need to learn. But to be able to give your boss a specific figure, you need historical data. Historical data. You need data, and that is the thing that we actually learned the last time. So, assuming that you have historical data in terms of your months, so let's say January, February, March, April, and May. And in all these things, the units that you've been producing is like, let's say 10, 15, let's say 20, let's give here 25 and 30. These are your units. And your historical data says that the total cost that you've been spending on these things are, let's say, 40, 50, 60, 70, and 80. All right. Now, in regression, all that you need to do when you have this historical data, and of course the examiner will always give you this historical data, is to label this one X. Say X is the number of units, Y is the total cost. It's good you give Y the amount. I will explain to you why. If you have this set of data, then all that you are going to do is that you need to generate a regression formula. So if the question now goes like required, calculate the total cost for, let's say, 18 units or 19 units or whatever unit, then what are you going to do? Or let's say you can put any number of units there. All right, so that is that. Now, if you are going to do this, or let's put 20 units. Let's put like 20 units. 20 units will be here. So let's go like 19 units. Because if I put 20 units, then the total cost is known. Can put anywhere in between. I will explain to you why. Then we will need our regression formula. And the regression formula is the same formula we've been used to do forecasting. Regression formula is given by y, which is equal to a plus bx. This is not new to you, is that not it? What is y? Y is the total cost. Y is the total cost. What is A? A is a fixed cost. You remember that, right? And you remember B to be what? The variable cost. Variable cost per unit, is that not it? Per unit of X. So X, therefore, will be what? The number of units. All right, because variable cost varies with units. So basically, that is that. Now, if we have this regression formula, then we need to find the variables. What then is A? So let's find A, the fixed cost. How do we find A in regression? Finding A in regression, A is given by the summation of X. All right, so let me put the X on this side. Let's go like this. So let me do it like this. The summation of Y over N. This is better. Then minus B summation X all also over N. So you can actually write it like this. But whichever way you write it is the same thing. All right. So because the B is over 1 technically. All right. Now that is how we find A. So in finding A, there is B. And so therefore, it is better that you find B first so that you can put the B into A. How do we find B? B is given by N sigma XY minus sigma X sigma Y all over N of sigma X square also minus sigma X square like this into brackets this. So sigma X into bracket square. So this is how you find B. All right. So when you get it, you can now slot it into the formula. Now, how do we get these things? Sigma Y, sigma X, Y, and all these variables. So all you need to do is to come here and square X, square also Y, sorry. So you just extend the table and square Y and also have XY here. So this is your sigma X. And if you add everything together, as you clearly see, 25, 45, 70, 100. So you have that. Then sigma Y, you add all those things, 40, 90, 150, another 150. That gives you sigma Y to be what? 300. So X square, let's square this, it gives you 100. Square this, you have 225. Square 200, you get 20, you get 400. Square 25 is 625. Square 30 is 900. All right. So you do that, you find it. Then that will give you sigma x squared. And together, this one is 2250. So that is what you have. Let's square our y. Squaring 40 will give you 1006 because 4 for 16. Squaring 50 is 25, so 2500. 36, 3600. 70, that's 49, so 4900. 80 is 64, so 6400. Add all these things together, that gives you like 19,000. So you have sigma y squared equals 19,000. Then we are multiplying x and y, so this and this, that gives you 400. Is that not it? 15 times 5, 75, so 750. And this one too is what, 12, so 1200. That's 2.5. That would be 1750. Yeah, that's it. 3 times 8, 24, so 2400. And if you put all these two together, you get sigma xy, and all these put together, that's like 6,500. So this is what you have. So this is all you need to do. Now, so you come and put them into the formula in generating the things you need. First is B, right? So let's talk about our B. So this is B. So if we have B here, and what is N? N is the number of observations, all right? Number of observations. So what is our observation here? 1, 2, 3, 4, 5. So you could see number of observations. So N here will be 5. Then what is sigma xy? Sigma xy is 6,500. So you put it in. All right. Then sigma x and sigma y. So we have 100 and 300. So 100, 300. All over 5 here. Sigma x squared. X squared was how much? 2250. So n 2250 minus sigma x, then you square that one. So sigma x is 100, right? So 100 squared. That is that. So what would B give us? If you work these things well, B is actually equal to 2. So that is what you have. All right. So now that we have B being 2, we can find A. Is that not it? So A is equal to sigma y. What was our y? I think y was 300. So just put in 300 over 5 because of the number. Then B, you found B. B is 2. And B is multiplying x, sigma x, which was 100. Is that not it? All over 5. All right. So obviously, this is 60. And if you do this one, what you are getting is 20. So this is what you get, 20. Now, this is our fixed cost. And this B help us obtaining our fixed cost. So now, in our linear regression formula, we need to find, if we need to find y, y now is given by 20 plus b. Our b is 2x. This is our regression formula. So if the question, remember this is total cost. If the question now says we should find the total cost of 19, we can say that our total cost y is equal to fixed cost of 20 and a variable cost of 2 by 19. So what do we get from here? So 19 by 2, that is 38. So this gives 58 cedis. All right, that is the total cost. Of course, if you put the zeros for total cost, you get, if here is in thousands, then you must as well put 3 zeros here. So basically, this is how regression is done. Easy, right? Very, very easy. All right, so this is what you go through and do for regression. Now, let's do some theoretical understanding of what we have just done. So the whole concept we've gone through is regression analysis, and it identifies the relationship between the variables on a linear relationship, all right? And when you are doing this, we talk about using a scatter diagram to find out which best fits the plots of XY axis. We did this when we were doing the learning curve, all right? Then high-low method, we've actually done that. Then this one, the least square regression, this is an advanced form, all right? And this one, personally, when I'm doing my research work, I use PLS, structural equation model, SEM. All right. So those ones, we have softwares that will help you do. All right. But when we take our regression, linear regression, this is a linear equation. All right. So that is that. The dependent variable, which is your total cost, as I've explained to you. We have the intercept, which is what is the value of y when x is 0, all right, or when x is particularly a given number. So A is your fixed cost, all right. At this point, when x is 0, here will be 0, so A will be standing, fixed cost. So it doesn't matter when there is production or not. B is the slope, the change, which is your variable cost, all right? All right, then the x is the number of units, the independent variable. It doesn't depend on anything because it is units. All right, so this is what we went through to do. And so you can pick this illustration as well. All right, so this is it, has 6 shops, so the n is 6, and this is advertising. So you can replace this thing with X and this one with Y. So this is the revenue that comes with it. All right. So you can actually basically go in there and do that. Now, the guidance is that as you have this information, you will just also do a simple thing like was done here. So let me just guide you. It's a very simple activity. So what you saw here, so generate x squared so that you can square this, all right? Generate y squared so that you can square this, then do xy so that you can multiply and get the totals, all right? So you see what I've done here, the summations are there for you, all right? So that is that. So here, it says that you are to generate the linear equation. That is what you are doing, the best fit for the regression analysis, and it is the equation. So you derive your equation here. All right. Let me thereby say that in the work that we did looking for our 19, you could see for 19 units, you could clearly see that 19 units is somewhere here. So when you are looking for the total cost for unit within the historical data, we call it interpolation. But if you were looking at something beyond this 30, let's say 50, 40, then for 40 units, then we are looking at extrapolation. All right. So basically that is that. This one is within the historical figure. This one is outside your historical figure, but it's the same thing. The equation will help you do that. So basically, if you look at this one, you go through and do this will be your regression formula, the linear regression formula. So mathematically, it's trying to say that when there is no production, the fixed cost that you will incur is 300. Basically, that is that. But where there is production, you will see that when you put the units there, you will start getting a total cost. The business interpretation of this equation is that when x is 0, unit of production is 0, our total cost that we will incur will be equal to 300. Meaning that if there is no advertisement at all in this particular question, If there is no advertisement at all, so then what is happening is that you will still get a revenue of 500 Ghana cedis. So basically, that is that. So for every 1 cedi that you spend on advertisement here, then it means that the revenue is going to be increased by 5. Because if you put 1 here, here will be 5, and it will be 305. So the number of advertisement that you do, which was your X, the number of advertisement that you will do will also determine the revenue that you get. So this is a pure business analysis. Have you seen that? So that is that. But in budgeting, what does it mean? So in budgeting, if you can see, have a proper regression formula, and your sales department can come and say that, oh, customers would demand, let's say, 500 units. Since you know that your Y is equal to 300 plus 5x, then it is easy to determine your total revenue. All right, it is very, very easy. So you will say that if I spend 500 something on advertisement, then you could see that here will change. Your total revenue will change. So if you are able to get the regression formula using the historical data that you have down, whenever you are given the X independent variable, you can be able to determine your revenue. Because what we do in our offices, and sometimes you wonder where they are getting the figures from. So when you see the budgeting, you see I've explained to you my practical way I used to do it when I was a finance manager of an entity. So I take it into my hands to do that. But unfortunately, for some businesses, so let's say you have January, February, March, April, May, and June. For some businesses, you don't know where they get the historical data from. They just sit down and say, if our last year revenue was 10,000, we project a growth of 5%, and therefore they multiply this by 1.05. Then all that they do is that 1.05 by 10,000. So that one will give them 10,500. And they will be projecting here 10,500. Then they will be doing an increment. But where came this 5? So what is the historical data they use in generating that? So that is the problem. If you're able to get a proper linear equation down for all your line items, you can be able to have proper figures. Like the way I started the lecture today, so that you don't give double shots to the manager. Is that okay? All right. So basically, that is that. All right, so we use it to do interpolation and extrapolation. So predicting outside the range, I explained to you, predicting in between the range, that one too, I explained that one to you. All right, so it is also used to do trend analysis. All right, so we were going to use this to develop what we call the time series, and that is what we will do. It helps you to know your cost behavior. You saw that, how to find the total cost. Cost behavior, because the variables that are given had meanings. All right, and this one will help you create good sales for your budget. All right, it is simple. You saw it. It depends on available data. You saw it. You can actually use Excel to do that. So all these things that I did, you can do it in an Excel. All right, so basically that is that. All right, so you can actually use Excel to generate this. Okay, so this one that I did, you create a column for this, 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 create a column for this. Basically, that is that. Is it difficult? Create all the columns that you need. Okay, that's all. So, of course, it is useful in forecasting. It gives you accurate figures. But the unfortunate thing is that it is based on assumption of linear, which means there is some linear relationship, some consistency, which is not always available. It is a two variable focus because we are using only these two, but there may be multiple variables. All right. Then the extrapolation, because you are doing outside, it is not really reliable. All right. So basically that is that. So you can go ahead and to solve this one. The final answer is here. All right, when you generate it, because it's 120 units, so you can see, just take a snapshot of it down, then use it to work this example, all right, per the requirement. That is that. So that is regression. The next part 3 in forecasting, we'll be looking at time series, which is also a very easy thing. When we are done with this one, then we start talking about the budget itself, the committee for budget, how budgets are formulated. Then we go into flexible budget, functional budget, master budget. Then we are done with budget. All right. So see you. Please make sure you subscribe, and I have the manual available. If you are not in our class, unfortunately, it's 350. But if in our class, we can give you a discount of 50 to 30 to 50 CDs discount, depending on your location. All right. So basically, that is that. All right. So make sure if this video is helpful, don't just watch it and let it slide. Just click the like button, and please subscribe. Very soon, I'll be bringing to you case study analysis, public sector analysis, especially in Ghana. So you have a full content whenever you are trying to do your ICAT exam. Bye-bye.